Hi everyone and welcome. My name is Henry. I'm an undergraduate co-op student with the University of Waterloo, representing the Department of Earth and Environmental Sciences. As part of my work term, I've been working on a simple approach to creating and using virtual field experiences in order to promote learning and bridge knowledge gaps in classrooms and labs, which is the topic of this presentation. As sort of an introduction, we've recognized the importance of students being able to connect and apply what they're learning in classes and labs to the work that they're doing in the field, especially in geoscience education. This is something we had the chance to address this past spring term in an online introductory geoscience course. What we wanted to do is see if we could use some sort of virtual field experience, or VFE, to inspire students to start thinking like geoscientists, which is one of the primary goals of the course. And by thinking like a geoscientist, we mean using and connecting spatial temporal systems and field thinking together. We came up with 3 objectives for our study. So firstly, what we wanted to do was create a VFE that improves students' geoscience thinking. That was our main goal. Secondly, we wanted to find out which areas of geoscience thinking students thought that they improved in the most. So which types of those thinking, like spatial or temporal thinking. And then finally, we wanted to see if a VFE could elicit specific moments of insight or comprehension among students. So our VFE of choice was a virtual tour. And a virtual tour is a series of 360-degree photos with added text and images. We were able to use free software. Google Tour Creator is a website that allows you to create these virtual tours and then host them on another Google website called Google Poly. So we decided on a 4-scene virtual tour. We called it SALT. And we created it around the idea of sort of the geologic processes and environments that contribute to salt formation. And we also described a little bit about how salt is extracted and then used by humans as a resource. If you have the time, I'd invite you to take a look at the tour through the link in the SALT virtual tour section, or you can scan the QR code at the bottom left of the poster. You can find the tour there. Part of creating our virtual tour involved designing these different tour elements in order to support the objectives that I've previously laid out. And these sort of tour elements are photospheres, which are the actual 360-degree photos that act as this immersive background environment. You have seen descriptions as well, which are text descriptions that give context to whatever photosphere that you've chosen. And then you have points of interest, which are these markers that can be placed throughout the photosphere, and when selected, they reveal associated text or images. And some of these examples can be shown in Figure 2 here to the left. The geoscience thinking diagram, which is Figure 3 on the right, with all the big colorful bubbles, shows how we were able to use the different tour elements to inspire those different types of thinking. In order to evaluate how effective our tour was, we had students answer 2 quiz questions about the tour after having viewed it, and we then sampled 100 of the responses from the 309 students that completed the quiz. The first question that we asked students was whether or not they felt like they were able to think more like a geoscientist after viewing the tour, and in which ways. So 90% of students responded that they had felt like they were able to think more like a geoscientist, and 75% said that they perceived that improvement to be in spatial thinking, which is shown in the left pie and bar graphs. The second question asked students whether they'd experienced a sudden moment of insight or comprehension, and if so, to describe it. So we saw 91% of students say that they did experience a moment of insight or comprehension, and these were mostly relating to how salt is formed or how mines operate. And this information is shown by the rightmost pie graph and bar graph. In conclusion, students did perceive an improvement to their geoscience thinking, mostly in their spatial thinking, so that was great. And we also saw that students overwhelmingly experienced some sort of moment of insight or comprehension while viewing the virtual tour. To summarize, we were able to demonstrate that VFEs are valuable for student learning, especially for their immersive capabilities and ability to connect what's learnt in the class and lab to what's practiced in the field. Thanks very much.